I am pitching this talk on the theme of listen, engage, think, and deliver. And it's about how projects, particularly the creative design projects, actually get built and that we produce something pretty spectacular. It's about two houses. So first of all, I just want to talk a little bit about material choice. There's a lot of talk there about innovation. Concrete as a major architectural material has been around for a long time, but since the 50s, it got the name Béton Brut, based on Le Corbusier in France, which led to the name brutalism, which led people to believe that it was a sort of an ugly material associated with large and pretty overpowering buildings. In these buildings we're going to look at, concrete was chosen a lot for its aesthetics. And interestingly, when we talk about aesthetics, I'm not sure how many people know that in 2012, a Hungarian company produced a ready-to-wear concrete line of clothes. And it included accessories and bags and iPad cases and whatever. And they were attracted by the color and by the shape and the crisp corners. Last year, Comme des Garçons produced Concrete, the perfume, which came in a little concrete bottle, right, and was particularly popular. So creativity and concrete pretty much go hand in hand. So in these projects, aesthetics was important. Skill set. Sydney has quite a strong tradition based on migrant involvement within the concrete industry, so we have a really good, strong skill set. Availability of concrete. Concrete, particularly in the last few years, has been quite available, and it's thermally efficient. Both of these houses, due to the thermal efficiency of the material, didn't need to use double glazing, and they managed to meet their thermal efficiency requirements predominantly because concrete was the feature material. Concrete's making a bit of a comeback. Some people say it since the financial crisis in 2009, people are looking for something solid, dependable, reliable. I just want to show you something a little bit different about how aesthetic houses can be. So the first project won the award in 2014, and it's called Glebe House. It also won Master Builders Award and won an Architectural Award. And so on this theme of the teamwork. Teamwork is what produces these projects and gets the result. It's the architect, the engineer, and the builder all working together from a very early stage is what produces the best. Second project won in 2017, and it's called Manley House. Sorry, I should have given you the team on that previous one. The architect was Nobbs Radford, and the builder was Youngkin Construction Group. And on this one, its architect was Popov Bass, and the builder was Horizon. And again, an MBA award. They have entered in the architectural awards, which I think have not yet been decided. So listen, we've got a lot of students here, so I'll just give you just a little bit on this whole listen principle. Always take minutes. Engineers are accused of being arrogant. We're accused of going into meetings with a fixed mind and not listening. Any conversation requires a listener and a speaker. Listening is a very valuable part of it. To understand the brief, you have to listen. And when you walk out of there, you have to understand that you've got the brief and what the intent the architect had in mind. So the first house is a Glebe House. It's an extension to the back of a cottage in Glebe. The front elevation of the cottage is there with very linear windows. The architect was attracted to that and wanted the extension to be a mirror of the original. They also wanted it to be a solid material, so they chose concrete. So when we came on to the project, the material was already chosen, the design was already chosen, and the linearity and the shape was there for all to see. The problem was that what he wanted was a checkerboard facade. And when we inquired about exactly what the checkerboard facade was, he wanted single point of contact between all the concrete elements on the facade. No overlap, single point of contact. So he wanted something that was spectacular and an interesting use of concrete. So the first thing that an engineer does is tries to persuade the architect to change his mind. We all do it. It's worth a go. Needless to say, you sometimes have to go away afterwards and say, look, could we really make this work? Could we give it a go? What could we do? So these were the images that they presented to us of what the house wanted to look like when it was finished. The architects are very creative in terms of what they produce. Engineers sometimes think that they're unrealistic. I would ask you not to prejudge, but let it run its course, check it out, run through all the options and see whether we can actually develop a system that can make these things work. So a lot of off-form concrete. The finishes had to be crisp and clean, lots of square corners. So a really crisp finish for a back extension on a small house in Glebe. Second project was the Manley House. And on the right-hand side there was the first meeting brief, which was taken in notes in our meeting. Concrete slabs, curved masonry walls, exposed roof, and floor soffits. Oh yeah, we want thin rolled edges. We want cantilevers up to 3.5 meters. And we want the building to run right to the boundaries, just to make all your formwork and make all of your construction difficult. So they, in this case, were after really something that floated. You can see the upper floor there floats on a number of steel columns. And the vision in this case was a light-looking structure made from concrete. Second phase in any design project is engagement. So after you've done your listening, you go away and you think about it. That quotation didn't go down very well in Ireland, by the way. You can do certain things with potatoes, but you do need to try other things. So sometimes it requires this lateral thinking. What can we do? How can we solve the problem? Rather than just a very simple first principles look. One of the other investigations they did with this building was to do a thermal study, and they used the 3D models. And you can see on that, it clearly shows that single point of contact, how crisp they wanted those corners. And they discovered that they didn't need double glazing, which helped them a lot in their detailing and how they fitted their glazing into the concrete. So, like I said, we went away and we gave them the obvious solutions. We said, why don't we have a nice big thick slab at the first floor? You'll see the edge of it in some cases, you won't in others. They didn't like that. We said, what about if we have a big thick slab at the roof and we hang everything from that? They weren't particularly happy with that either. And what I need to point out is that behind that facade, for about 2/3 of its length, is a void. So there's not an awful lot of cantilever backspan and stuff that you can do with it. So the next thing was to start to think about illusion. So this is M.C. Ecker from 1953, and the concept here was to graphically show 3D in a 2D plane. So when we started to look at the design of this facade, it's actually a 3D facade because the columns have a certain depth. But visually from the outside, you want to see a 2D image. So the concept here then was the reversal of this. It was to turn a 3D structure into a 2D image. On the Manley House, this is a bit of a demonstration of this whole engagement thing. This is this first stage of the architect sends you your drawings, you scribble all over them, you send them back. We now use Bluebeam and some other sophisticated electronic ways of doing it, but the process is still the same. It's a two-way conversation. Sometimes you can get the builder involved early, and that is what produces often the best results. You're getting a good understanding of what they can do, what formworks they need, what section sizes are best. And so this continues for a number of weeks. I've shown you the polite comments ones. Sometimes you get the triple question marks and the what the, and are you joking, right? I've kept them off this one. So you can see they were quite demanding in terms of the edge treatments. In a couple of cases, we did have some sloping glazing that we had to incorporate into the concrete. We have to run our downpipes, our drainage through them. You have to look at the falls. How is water going to get away? How do we prevent water from getting in? And how do we give that lovely, crisp, clean look along the edges of the structure? So then comes the thinking stage. So sometimes you've got to step back. And a lot of what's involved in these processes is the spark of that interaction with other creative people. So engineering is a creative pursuit. You're using your skills and you're using your experience with someone else who has very little understanding of the mechanics of the situation. And between you as a group, and again, if you can get the builder involved, you evolve a solution that solves for everyone. A bit of compromise on all sides, but it's about getting in there and releasing some of those prejudices that sometimes we're accused of. So this is what we came up with. So we used the depth of the facade to actually create a sloping soffit on the sections which were visible at the front. And I don't have a pointer here to show, but if you have a look at that very first slide, you'll see that the facade is in different beams that intersect with one another. And the exposed ones at the front have a sloping soffit that goes downwards, and the ones that are not exposed at the front have a sloping soffit that goes upwards, or a sloping top that goes upwards. And between the two, we get this triangular zone of intersection. And through that, we're able to run enough reinforcement that ties the whole of the facade together. The other problem was that the column sections, the C sections that run across the front, you can see them here, they don't align. So the back legs are splayed, and they don't cross over by very much, except for this beautiful shape that we have here. So to get our vertical continuity in our columns, we have to rely on running our compression through that zone and running our steel through that zone. So you can start to see that, yeah, sometimes it's a difficult problem, and yeah, you can come up with a solution, but then you have to build it. So we looked at precast, because again, it was all about the finish. How can we get those nice clean finishes? You do it, you precast. You put everything in a precast workshop, it's all done inside. You can do some of the elements on the flat, so you can get a much better quality finish. But when you see the amount of components and how different they are and what's involved, bearing in mind that this is at the back of a terrace house in Glebe, you start to think this is not really physically feasible. But you still have to go through that, because it starts to inform that whole discussion going forward. With the property at Manley, we had a different problem. The architect wanted to have a skirt the whole way around the building of an exposed slab soffit with the cantilever up to 3.5 meters. He also wanted heavy masonry curved elements on the facade on the upper floor. So we all know that if you put heavy brittle masonry on a 3.5 meter cantilever, you need to have a fairly substantial concrete slab. Except we weren't allowed to have a substantial concrete slab. And when you see that dotted zone in the back there, that's where you wanted a recess. You want to run all these services and all these lights and everything through there. And he said, yeah, maybe 200, 240 thick I'll give you, right? So the solution in the end was to put a concrete wall at the very end of that cantilever and to use a push-pull and a diagonal so that we turn the wall actually into a hanging column, which transfer the load back onto that column and turn the cantilever from 3.5 meters into something around about 1 meter. And then we put a torsion beam the whole way around that void, and that took those loads back into those columns and rectified everything. So we were able to give him his recessed ceiling zone in the middle. We were able to give him his 3.5 meter cantilever, and we were able to give him his nice rolled edge around the outside. So that's the detail of the column. And of course, with everything else with these, is that column with the brick skin on the outside had to match the thickness of the cavity brick everywhere else. So again, we're restricted with the thickness of the column that we could actually use. Okay, so the engineer's done his job, the architect's done his job. We've got to get it built. I like this comment, because in a lot of cases you have the best drawings in the world and you go to site and things change, conditions change. You've got to react to what's there. So you need to have a good builder. So Yunkin had superb formworkers. They reckoned it was one of the hardest formwork projects they ever did. So to get that overlap, the reversal of the formwork, those very small transition zones, and you look at that reinforcement in those photographs, beautiful. I mean, it's not often that you go to site and you see reinforcement so beautiful. That is more what you would expect to see in a precast yard where the conditions are benign and you have beautiful steel forms and everything stable. This has been done in a small project, in a domestic project. Absolutely beautiful work. They managed to do this in 12 months. They managed to do it on budget. So again, it's this having the right skill set, having people with a can-do attitude. So you need to have a visionary architect who comes up with a really brave scheme. You've got to have engineers that want to say, yeah, we're going to give this a go. And then you want to have a team of builders, formworkers, concreters, who have that real skill and passion and take that and drive it. So this is the evolution of it. And you can start to see, I hope, there a little bit about these overlapping slabs. You can see on the edge there, you can see how the slab is at 2 different levels, right? And you can see that these intermediate ones have the sloping soffit, but from the face, you actually, in that first photograph, you don't really pick that up. It looks like it is a checkerboard solution. And there it is in all its finery finished. So the architect was happy to see that joint. We sometimes obsess a lot about hiding joints. You know, structures, engineers love to see structure. We love to see it real. We love to see how it goes together. So people can see, yeah, that went first and this went next, right? And sometimes we obsess about getting our joints right. But in this case, you can see the patterns of the formwork, of the bolt connections, of the slabs. And again, that beautiful thin line right up at the roof, where the roof comes out. And that gives a full sense of the checkerboard. And then when you look at it on the inside, again, that fantastic formwork. Those lines are crisp and clean. So if you remember back to that very first visionary 3D image that the architect presented, I mean, that is as close as you can get. And then that photograph on the right there, on your left, is the internal view of the facade. So you can see the slab running right through, right? And then there it's all at one level, because what's happening is the soffits and the top surfaces are changing. But again, everything comes together, it's crisp and it's clean. It's a beautiful piece of concrete. And there's that void I told you about, where we couldn't have a backspan, so it really restricted how we could cantilever through. So I was lucky enough to go back. This job was finished in 2014 recently, and it still looks just as crisp and clean, as beautiful as when it was built. Oops. This is the other side, of course. If we had lots and lots and lots of money, we could build lots and lots of wonderful things. In the Manly job, lump sum tender, right? The killer on projects like this is variations. So if you don't have it detailed properly, if you don't look at where everything goes together, you're going to get crucified. So in this case, the builder was not brought in early on. He suggests that he could have contributed a bit to the process and maybe improved how it was built, but that he was fairly comfortable with the drawings and with the contract. Again, we explored the whole notion of precast. We're right opposite Manly Beach, and we wanted to make sure that we got all our covers right, that we didn't have a problem with the durability of the structure. The challenges here were that the formwork right had to go to the boundary, so it had to get cantilevered out from back inboard. And on the left, on this side here, this is our concrete wall. Interesting point he makes about the fluidity of this process. Nothing's really fixed. You do your drawings, you go to site, you've got to work with it. It's going to change. Something's going to happen. So the engineer has to be fluid, can't be rigid. It's part of that process. So all through this is the teamwork. The architect, the engineer, the builder, all working together towards producing a whole. So you can see those beautiful curved forms. They made a prototype. If you want to get concrete, uniform, you want to get color, you want to get consistency, you've got to do a prototype. You've got to make sure that the color of the concrete is as close for each of your pours. You do that by getting your concrete from the same plant with the same mix. You make 1 or 2 samples. And then you do the crucial thing, is you get the architect to agree to it. One of the advantages of having a panel that you can say, look, that's what you agreed to, is that when this assessment happens afterwards, as it always does, and someone says, oh, this isn't really what I wanted, you can point out and say it's exactly like the sample panel. Always recommend doing sample panels. So again, now you can see that beautiful rolled edge. You can see the junction of the column to the concrete. So the cap plate is inside within the column, or within the slab. Again, the form boards, the alignment of all of that, so that the whole concrete finish is as pure as you could get. Some more images. So as an engineer, when the architect comes back and says it's built on budget and on time, that's a pretty commendable thing to get. Because in the pressure situation where we are now, we are asked to produce documents in a very decreasing fee market. And one of the ways of boosting your fee is to build in contingency, or to build in, there's a tendency perhaps to not give a design what it might be due because it's a cheaper thing to do, or also to try and gain some additional fee by having more difficulties on site. That, of course, is a penalty to the client. And it was rewarding on both of these projects to see that they came in on budget with very little disruption on site and absolute harmony. And it was nice to be able to ring up the builders in the last few weeks and say, I'm going to give a talk on this. Can I pump you for a couple of quotations? And for them to give that willingly is a really nice thing to do. So in summary, what I would say about this stuff is never say no, be open, listen to what your client's brief is or your architect. Work with them, engage with them, and explore lots of different solutions. And then think about some creative ways sometimes of delivering. So whether it is that wall that acts as a push-pull and reduces the cantilever span, or whether it is that 3D facade that actually looks like a 2D image. These are all skills that structural engineers have. And another few of those images that just again show the glory of that cantilever and how it looks. And that's the tale of two houses.